Now the third example is the spring. Okay, in this diagram the spring is in natural state. It means there is no force acting on the spring. Okay, now in order to compress the spring, we have to apply force from this end and push the spring in. Okay, okay, now during compression you have to exert force on the spring. Okay, and the spring gets displaced, okay, from here A to B. So there is a displacement. Okay, so this is the direction of displacement. And also this is the direction of force. Okay, you apply force in this direction, and also the displacement take place in the same direction of the force. Okay, so there is a work done by this force. It means you have to do work in compressing the spring. Okay, and in compressed state the spring possesses potential energy. So where did this elastic potential energy come from? The work which is done by you in compressing the spring. So this work is transformed into elastic potential energy of the spring. Okay, now in compressed state the spring has elastic potential energy. Now if you place a ball here, okay, and release the spring, then what will happen? The elastic potential energy is converted into kinetic energy which is possessed by the ball. Okay, when you release the spring the ball comes into motion. Okay, and this moving ball possesses kinetic energy, and this kinetic energy comes from the elastic potential energy stored in the spring. Okay, so this is the transformation of work done into elastic potential energy and then into kinetic energy. Okay, note it down that work done in compressing the spring is converted into elastic potential energy. Okay, and this elastic potential energy is stored in the spring. Okay, now when you release the spring, then this kinetic energy, this elastic potential energy is converted into kinetic energy. Okay,